Thank you very much. Let's talk about A first, right? Then you can continue. So A, you have a random, see, no, you have a random sample to start with, and then you record the sex of the student and ask if they are not in Greek life, yes or no. Okay, so if you group them by their sex, then the response will be the other variable. Because if you group people by sex, you're saying the explanatory variable is the sex. Good. So the response is you're trying to predict. Does sex help you predict the propensity, the likelihood of someone being in Greek life? Very good. But if you had grouped them by whether they were in Greek life, then what would be the response? Of course, it's the other variable. I mean, could we do this as well if we wanted to? You can use participation in Greek life to predict the sex of the person. But I think the more natural one is the first one. But there's nothing wrong with doing the second one. It depends on what you want to do. Can you generalize? Yes, because it's a random sample. These are fantastic answers. Very good. But can you make a causation claim? No. If you find that one sex is more likely to be in Greek life, all you can say is sex is associated with likelihood of being in Greek life. But that's where it ends. You cannot say causation because, yeah, this could be many things are associated with sex of the person. All right. So this is just one of them. So you cannot make causation. Very good. Let's look at B. Since you all have been so efficient, B, you have, see, a sample of your hope friends. So no mention of randomness, just your hope friends. And this is very much what students do when it comes time to do the project. So you randomly assign someone to read using font A, and other people will get randomly assigned to font B. So you read the identical words, maybe it's a story, one paragraph story. Same words, some people read in font A, some people read in font B. Then you ask questions and you record how many you get correct or wrong. So these are actually, I'm actually giving you potential projects you could actually do. Okay, so it's something someone has already asked me about projects, actually. Projects I'll talk about after spring break. So not yet. You have to learn a little bit more stuff first, right? But then, so I think the most reasonable choice is the font. Good. Isn't the font a natural bucket to put people in? You saw font A, or you were assigned randomly to see font A. You were assigned randomly to see font. Very good. Now, of course, you can put people in buckets about how many they get correct, but that seems a little bit more weird. That's all. You can't. You got 20% correct. You got 40% correct. And then from there, you try to predict backwards and say, what font did you see? That's less natural, I would say. That's why I say, what's the most reasonable choice? Font assigned. Can you generalize? You cannot. You know why? Because these are your friends only. If you really wanted to generalize, you can only generalize to people who are like your friends. What does it even mean? See? Okay. And then you can make causation. Why? Was this an experiment? Did you randomly assign the explanatory, which is font? Yes, you're told. You flip a coin. Heads, you get font A. Tails, you get font B. Something like that. All right. Now let's see. Look at C. You have a random sample of Holland residents. You record their household income and their average utility bill. Very good. Okay, it's a simple study. If you want to predict utility bills using household income, what is the explanatory? Good. You didn't get tricked by the order of the words. You are trying to predict the utility bill. That's the response. So the explanatory, the other one. Very good. Can you generalize? You can, because you can generalize all of Holland because we did start off with a random sample. Very good. Can you make any association? You can make an association. I think you will find in this study that the more a household makes, the more likely they are to have a higher power bill or utility bill. I think that's pretty natural and pretty bad. But you cannot make causation because this was not an experiment. Nothing was randomly assigned. You didn't assign. How can you assign household income? How can you? Okay, so it doesn't make sense. So it's an observational study. You can only make associations. Good. You sample your residence hall friends. So I hope you picked up on that. Residence hall friends can't be a random sample. They're just people in your residence hall. So you don't have a random sample. You ask them their major and their GPA. Okay. So if you group them by their major, then the response will be the other thing. You group them by their major, means major is the explanatory, which means the response will be the GPA. Good. You cannot generalize because you don't have a random sample. It's just people in your hall, which I think makes sense, right? You only ask people in your hall. How can you generalize all of hope, right? You can only make and you can only make a causation. In other words, let me ask you: is this the lowest quality study actually that you can think of? Is study D pretty bad, right? In limited in what you can do, you cannot generalize and you cannot make causation claims. See, this is the in the brain meme thing. I don't mind telling you, this would be the first one. Very low quality study, not a wrong study, but low quality because you cannot make causation claims and you cannot generalize. Okay. Now E. See, random sample of students at Phelps, you randomly assign one kind of music and you record the time it takes to solve some kind of math problem. Actually, I'm kind of hoping some of you do some of these for your projects, honestly. I'm giving you so many ideas. So they're not hard to implement. Okay. For E, what's the most reasonable choice? Okay. I think this hasn't been completed yet. So why don't you try? Okay. So you have a random sample. What's the most reasonable choice? I would say music type. Yes. That's a natural grouping. You were assigned to hear randomly music A, and you were assigned to hear randomly music B, something like that. Good. Can you generalize in this case? And I hope the answer is easy. You can you generalize in this music study? You can generalize because you're told you have a random sample. What kind of conclusion can you make? Can you make a causation? Let's say one kind of music is linked to, I don't know, getting the answer faster or whatever metric you are imposing on your study. You can make a causation. The music is responsible for that. Suppose experiment. You get it? Very good. Last one, F. Students in our class, you ask each one their year in school and how many credits they're taking this semester. Okay, I hope you realize this is one of those low quality studies. This is students in our class. Is it random at all? No. So you cannot generalize. If you group them by their year in school, what would make the response variable? So you're grouping them. The explanatory is year in school, freshman, sophomore, junior, senior, right? If you did that, then what would be the other variable that would be the response? The response will have to be the number of credits they're taking this semester. That's right. You cannot generalize, and therefore, because it is also not an experiment, if you find some kind of connection, all you can make is a what kind of claim, right? I hope you realize there is no random assignment of anything. You can't randomly assign the year in school. You can't randomly assign people to take how many credits you want. So this is a classic observational study. And so you can only make an association. Maybe some majors are associated with taking more credits, but that's where it ends. Very, very, very good. All right. I didn't help you all much at all. Okay. So you know what? It's so hard to type in the picture. It's horrible. So we'll go with, what happened? Ugh. Okay. Let's call the brains 1, 2, 3, and 4. Okay. In increasing amounts of quality. Can you just put letters after the equal sign? So the lowest quality studies are represented by which letters? There's 6 studies A to F. Which ones are the lowest quality studies? Can you find them? Yes, I agree. F is one of them. There is one more, I believe. I think there is one more. F is a low quality study because it is an observational study with no random sample. Can you find another observational study with no random sample? Yes, good. D is another one. If you read the description for D, it's a sample of your residence hall friends. You record the major, and so this is clearly a classic observational study that doesn't even have a random sample. So that D and F are the lowest quality studies. Very good. Is E the highest quality study? Is it an experiment with random sample? Let's check. So E is the music study. See, you randomly ask people in Phelps and you randomly assign the music. So this is an experiment with the random sample. So yes, highest quality study. What about the remaining letters? So we have done E, F, D, D, E, F. What about A, B, and C? Where do they belong? Where does A belong? Study A was what? Random sample of Hope students, record the sex of the student and ask if they are not in Greek life or yes. Okay, I think I have the answer. Study A would be a what number? Did you have a random sample in study A? You did. So it's slightly better. But is it an experiment? No. So that would make it a number what? Which brain is it? Good. Good. What about B? All right, let's look at B. Where does B belong? Study B is, see, you have a sample of your Hope friends. You randomly assign, okay, so there's some random assignment of the explanatory, but it's not a random sample. That would make study B what number? 3. Good. It's an experiment. But it doesn't qualify to be a 4 because you didn't have a random sample. It's not as good as it could be. Very good. You're getting it. And the last one, C. Where does C belong? Okay, let's see. Is C a study? Okay, is C an observational study? Yes, and it's a random sample. Good. So it's slightly higher quality. It is a random sample, but it's an observational study. It's not an experiment. So it's study number 2. Very good. Okay, so I hope this helps. Okay, I love this meme because it is exactly 4 classifications. It's very good. I saw someone added a 5th one, but we won't go there. Right? Whatever. Okay, in some other place. Okay, I want us immediately to work on this very simple worksheet. Now, this will introduce chapter 5, all right? And I believe all of you are capable of doing this. We will also discuss on Scratchpad. I think it will only take you 2 minutes, honestly. It's a very, very fast one. 1, 2, 3. Let me call it up and we will talk about it. Okay, do it on the paper first. Then we will put it on Scratchpad and you can contribute your answers, okay? You can fill in the totals first, that will help, right? Fill in the totals first, then that will help. Good, right? I mean, you just total it to, so you know how many males there were and how many females there were. That will help. Good.
Okay.
This is excellent, by the way. Is this an easy exercise? Right? Isn't it? Okay. Well, because in about 2 minutes, we will be starting this kind of thing. All right. That's why I want you to warm up a little bit first. Do we agree with this one? What's the sample proportion of yes among the males? You take how many yeses there were and you divide by 63. Who doesn't know how to do this? Right? Now you'll be surprised. Let me tell you, in my last final exam, I had at least 4 students not write 26 out of 63. I'm going to ask you, can you guess what answer they gave me? Not 26 out of 63. Can anyone guess what they wrote? I'll give you a hint. It started with 26, okay? But didn't finish correctly. What do you think they wrote? And I'm telling you this because I want you not to do that. Right? Anyone can guess? What did they do? It wasn't just one, right? This is correct. But what they did was not correct. Yes. Oh, that's a good point. No, they didn't do anything as sophisticated as that. Can you guess? Yeah, I want to. Yes! Don't do that. They did 26 out of 37. 4 students. 4 in the final for an intro step class. It broke my heart. Because it means I failed. How can you have 15 weeks of statistics and think that the answer for this is 26 out of 37 that I failed? So don't do that. No one. I hope no one does it. I'm waiting to see whether anyone does it this time. But it's 26 out of 63. Just because this was not given, they didn't realize that you have to find. You see, I think that was the problem. I think if I gave the whole table like this, they might have got it correct. Okay, but anyway, that's the point I'm trying to make. Do the same for females. Calculate the difference. Um, that's very interesting. You are putting an absolute value. Actually, you don't have to, because depending on the, if I say male versus female, I think I'm saying male female. You're doing a male versus female. So actually, don't put the absolute value. Okay, this will be the absolute difference. That's a story for another day. Thank you very much. This is very mathematical. You don't need to do that. Negative answer is fine. All right. So let me talk a little bit about this. There's only one thing I want to introduce. What do you think is a symbol? I'm so glad to see a p hat. Not pi, please. This is an observed statistic. But now do you realize we have 2 p hats? In math, you must distinguish. And so here's something new for today. You add something as simple as an underscore p hat male. You get it? Okay. Simple, right? P hat male. It's now necessary to say that because which p hat do you mean? There's p hats all over the place. Which one? So this is a male p hat. This is a female p hat. Okay. And one last thing. What is the symbol for this? Can you guess? This is kind of a trick question. There's no special symbol. This is just p hat male minus. That's it. I can't express this in any less clumsy way because this looks like this cheating, right? It's not a new symbol. Yeah, it's not. What I'm saying is, how would you write this in symbols, basically? Not a new symbol, but it's PS new minus payment. That's what you're doing. Good. So can you see that there's not much difference in the sample between what males and females think about something? We didn't tell you what the yes and no was in answer to some feature. All right. Very good. So I think we are very primed now to do this part of the class. And today's class will not be difficult because if you have been keeping up with what you have been learning with me, a lot of it is going to be just extensions of what you know. Okay. So you should have this ready. I think I sent an email quite some time ago already. This is chapter 5. You're going to be comparing two proportions. So this activity was supposed to be a warm-up to this kind of data. So I have here a very simple data set to understand. I had a group of people, I recorded their sex, and I asked them a simple question. Do you own at least one gun? You either say yes or no. Okay? So you see, is this a yes or no question? Yes. That's why we're interested in a proportion. There's nothing new here. It's the only thing new here is I'm asking this question to two groups of people. That's it. Males and females. You get it? Okay. So we have a random sample. Okay, take note. We have a random sample of US adults. These are random sample. Two variables are measured on each adult. Anyone care to tell me what they are formally? The two variables that I measured were, do you own at least one gun? And this one sounds a bit weird, but what did I measure as well? Sex. Good. So there are two. Now let me ask you a question. Which variable do you think is the most reasonable choice for the explanatory? What's the most natural bucket you put in? Remember, the explanatory variable is the bucket variable, the grouping variable. What is the most natural grouping for this kind of data, would you say? You could say either answer, honestly. Either variable could be explanatory, but what comes a little bit more naturally, I would say? I would say sex. I agree. I mean, can you group them by gun ownership and then predict sex? You can, but I think it's more natural to just group people by sex and then just ask whether you own a gun or not. Something like that. Good. So I think the most reasonable choice for the explanatory is sex, and therefore the response has to be the second one. Okay. So I'll tell you why this data set intrigues me. It does because you must understand. Uh, Before I came to the US to do my PhD, I had never set foot in the US before. So I had just landed about a week when this incident happened. No, nothing. This is not a shooting incident. Don't worry. But no, it's not. It has a. Okay, but here's what happened. So after 1 week of being in the US, my apartment building. I was in Iowa, by the way. I didn't do my PhD in Michigan. I was in Iowa. So I lived very close to a Wendy's. Okay. And so one night I was feeling hungry. So I thought, I'm going to get something to eat. So I went there, and then I saw a sign on the door, which I have never forgotten. You know what it said? No concealed weapons on the premises. So when I saw that, I was like, whoa, what country have I come to? Okay. So because notice it didn't say no weapons. Yeah, a gun is fine. Just don't hide it. No concealed weapons. You want to show me your gun? You can. But don't conceal it. So I'm like, whoa, where is this? Okay. So I never forgot it. And you must understand, I come from a country where no one has a gun. You can't get one. So no one has a gun. I know there are arguments that people who want one will always get one, and we do have people who illegally have them, but it is very, very small, the number of people. But anyway, this was a huge culture shock, and that's why this kind of data set is very interesting to me, and just giving you some background. I know it's very natural in this country, but it's very unnatural in many places in the world. And where I come from is one of those examples. Okay, anyway, determine P hat men, P hat women. See, I've introduced this concept already in your worksheet. Can anyone tell me? You don't have to tell me the number. What would you do to get P hat men or P hat male? What would you do? What would help as an addition to this table that's not on the table originally? If you want to find P hat men, what did you do in the worksheet? Yes, it would help to get a total, find out how many men there are, then find the fraction. Does it make sense? So I have the answers in the slide. I'll show it to you now. Do you agree that P hat men is 821 out of 2105? If you find the totals, you'll find that there were 2,105 men in the center. And you do the same for the women. Notice also that p hat is measuring the yeses. It's the fraction of yes. So I'm going to ask you all whether you can tell me the words that you should use to define pi men. Okay. Every time you see pi, what are the words that should come out of your mouth almost reflexively now? Pi is a long run proportion. Yeah. But in this case, the long run proportion of, why is the word men here? That's right. The long run proportion of men who own at least one gun, was that very hard? No. That's why all the foundation has been built, and now class will actually become quite exciting and fast, really, because there's hardly any new things anymore. It's just now that it works in groups. So the long run proportion of US men who own at least one gun. You just have to slot in the word men. Previously, when it says long run proportion of people who own at least one gun. Now it's that, okay, long run proportion of, it's still a long run proportion, but now it's for the men. Can you, of course, do a pi women? All right, of course, pi women is just change one word. Long run proportion of US females who own at least one gun. See? What is the percentage of US women who own at least one gun? We don't know this number. What is the long run proportion of US men who own at least one gun? We also don't know this number. So they are parameters. One thing I want to note is, again, some people think that pi men is the long run proportion. Okay, listen carefully to this. Some people think pi men is the long run proportion of people in the US who are male. That's not what pi men is. It could be in another study. But this is not a demographic study. We're not looking at what fraction of US is male. That's not what pi male means. Pi male means among the males, among the group that is male, what's the fraction that own at least one gun? See, pi men. So one way to think about this is the variable in the subscript is the grouping variable. See, sex. The explanatory variable is in the subscript. So that groups them, and then the pi talks about the pi for that group. Okay, so good. I think we're doing well. What is the null hypothesis here? The null hypothesis is pretty easy. The null says pi men and pi women are the same. So the same theme applies like what you're used to. Remember I told you before that the null hypothesis is the one with the equal sign? That's still true. The null hypothesis is the one with the equal sign. The alternative is the one with the, well, greater than, less than, not equal to. That's still consistent. The only difference now is this. Remember when you did one proportion with me? What did the null look like? Wasn't it pi equals something, 0.5, 0.6, 0.55, whatever it is. So that was the form. So this was a number last time, and there's no groups. Just pi equals something. Now you have groups. The key interest here that we want to look at is whether these two groups have the same proportion. Is pi men equal to pi women or not? So the null hypothesis says that they are the same. All right. So digest that first. Now, why am I testing this? Because I want to. Can I test other things? Of course. In this example, I'm testing greater than. Okay? So this is a one-sided test. Okay. This is equivalent to state this in another way, like this. First of all, do you agree that this and this are the same? Again, stare at it a little bit carefully. Some students have problems with this, so I'll go through this again. One way to write the null is to say pi men and pi women are the same. That's perfectly okay. It is also mathematically equivalent to say pi men minus pi women is equal to 0. Now, what has come as a bit of a surprise to me is that some students really have a hard time seeing that these two are the same. That's why I'm writing it like that. I mean, doesn't it make sense? If I say A is equal to B, aren't I saying A minus B is 0? Right? If I say two things have the same price, isn't the difference in price 0? Right? It's two sides of the same coin. So you either say this or you say this. Now you might be thinking, why am I making this a big deal? Like, why even introduce this form? This form has some use, but you can choose either one depending on what you like. They are the same. All right, they are both saying the same thing. Just be aware. All right. Okay. Let me ask you a question now. If the null hypothesis were true, now notice the if there, you never know whether the null is true or not. But let's say the null is true. What do you think will be the size of this difference? This is the observed proportion of men who have guns versus the observed proportion of women who have guns. Now, what does the null say? The null says that in the long run, you say, okay, let me go back to what the null says. The null says that in the long run, men and women own guns at the same rate in the population. We are here to show whether that's plausible or not. The null says, status quo says that men and women in the US own guns at the same rate or percentage. So my question to you is this, if this were true, if what the null says is true, would you expect an observed sample proportion of men who own guns versus an observed sample proportion of women who own guns? Would you expect this to be small or big? Very good, fast as well. Small. Why? If the null is true, what does the null say? The null says that in the population, men and women own guns at the same rate. If that is true, your sample that you get should reflect that. You should have not a big difference. Notice, I'm not asking you whether this is big or small individually. I'm saying is the difference small? Because the null says there's no difference. So in the sample, there should be very little difference as well. Good. So you anticipate this to be small if the null were true. Hang on to that. All right? Does it make sense, therefore? Okay, so small or close to zero if the null is true. Which means you can test whether the null is plausible by checking the size of some kind of statistic that involves this difference. So if this number becomes something big, then it means that this difference is big. If this number is small, it means that this difference is small. And notice what's this statistic called? Theory Z. Okay, now this is the beginning of a little bit of a repeat notation. All the standardized statistics involving proportion so far, they're all going to be called Z. Whether it's a single proportion one, the p hat minus, let me call that up, okay? Let's not talk in theoretical terms. Let me show you. You have been introduced to one theory Z so far. Let me show you in the summary, all right? Here it is, okay. Okay, remember this one? You should, really. Theory Z is p hat minus pi over square root pi 1 minus pi over n. Remember this one? Okay, this is theory Z. Notice, let me point out the structure. Observed p hat minus status quo statement over some square root thingy. All right, so we have that. Look at the modified theory Z now in the more complicated two proportion case. Does it make sense to you? Are there parallels that you see? Isn't this the observed difference that you see? So you put the observed difference. Last time there's only one p hat. Now you put the difference here. And then you subtract zero. I'll talk about that in a minute. You divide by square root of something. This is also called Z. Everything involving standardized statistics with proportions is always called Z, unfortunately. Context will tell you what Z I'm talking about. So when I say calculate a Z score or a Z statistic, you have to look at what scenario am I in? Am I looking at just the one proportion? Am I looking at two? Because they're all called Z. Just like you will also see they're all called T as well. We'll get to that. They're all called Z. Which Z it is depends on the context of the problem. If it's a one proportion, you go back to the one proportion Z. If it's two proportions, you go to this one. So they're all called Z. Okay. So I usually tell this to my students. I don't know whether anyone takes foreign languages at home. Some students take Chinese, and Chinese is a tonal language. It's known for its tones. If you have studied any Chinese, and that usually makes it very difficult for people whose first language is English, because English is not tonal in that sense. When we say your tone of voice in English, we actually mean the volume at which you're speaking and the rate at which the words come out. You know, when people say, I don't like your tone, they don't mean that you're saying your words with a certain intonation like in Chinese. What they mean is they don't like the amplitude, I mean, how loudly you're speaking and how quickly you're speaking. That's basically it. But in Chinese, and that's just one language that's tonal, but it's just very widely spoken. Chinese has tones, Mandarin has five. Okay, so I've often asked students this. There are Chinese songs, and songs have a melody. How do you know what the person is singing about? Because when you sing, the tone of the language disappears, right? You have to follow the pitch of the music. So the context of the song tells you what the words mean. What I'm trying to say is, in Chinese, the same sound can mean a whole host of things depending on the tone. So when you sing, that identifier goes away. That's kind of like what's going on in it. All of them are called Z. But which Z it is the context of the problem. The context will tell you which Z to use. And if you're talking about two proportions, basically. I mean, most songs are about love anyway, either falling in or falling out of. So, um, isn't it true? Across all cultures, well, I mean, country music, what are the three themes? Uh, Falling in and out of love, pickup trucks, and dogs. Right? So, you you can't you kind of know. You can even say like what are a lot of Taylor Swift songs also like breakup songs or something like that. You kind of know the theme already. So the context will tell you which. I don't listen to her music. I can't. I don't understand it. Those things. I can't relate, but she's very, very popular. Okay, so anyway, so do you agree that theory Z makes sense? Okay, now I have kept this something here for a reason. I've hidden it because I'm going to show you in the next slide what it is. It's something pretty horrible. All right, I don't want you to be distracted by that. I want you to see that the overall structure is the same as the Z that you know. Does anyone know why I put the -0 here? It's not necessary. When you do this in your homework or when you calculate, please don't waste time typing this into your calculator. You know subtracting 0 does nothing for you. But why do you think Professor Cole has put a -0 there? I have not gone completely nuts. There is a reason. You don't have to when you calculate, but I'm doing this for pedagogical reasons. Does anyone know why? I'll be very happy if someone can tell me. Why do you think I put a -0 here? I'm trying to show you a pattern. Why? All right, I'll give you a hint. I'm going to flash to what you know in chapter 1. See, in chapter 1, your theory is p hat minus pi, and pi is what the null says it is, right? Now, we don't have the same null hypothesis, but we have something very similar. So why do you think there is a 0 here? Does anyone know the answer? Yes. 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 Hey, Jason. I'm so sorry. There's only so few guys, and I got your name wrong. I'm so sorry. Okay. Oy, okay. Okay. So, that's exactly right. The 0 is what the null said. What does the null say? The null says that pi men minus pi women is 0. So in other words, I'm trying to remind you that this is always observed minus hypothesized or status quo statement. See? That's why. When it was one proportion, you say something about pi, the null says pi is something. So you put the pi in the z statistic, p at minus pi. Now, the null says pi men minus pi women is 0. That's status quo now. You dump status quo. It's always observed minus the status quo. It's always like that. See? That's what. But when you calculate, please don't waste time writing that, okay? It does nothing for you. It's just a teaching device to show you the parallel. So if theory Z is large, is this evidence against the null or no evidence against the null? If you have a big Z value, what does this tell you? It means the disparity between men and women is big. Is this evidence against the null? Yes. Yes. If you get a big theory Z, this is evidence against the null. There is evidence that the long run proportion of male gun owners is greater than. So you go for the alternative. Reject the null. And you know, once you calculate the z, this functions exactly like what you're used to. Go look at the z table. That's why it's called z. You go to the same z table and get your p-value. Okay? That's why we spend so much time teaching you how to read the z table. Nothing has changed here. Only the z statistic has a slightly different form. a bit more general. That's it. So if your Z is large, it means that men and women are quite different when it comes to gun ownership in the sample. It is so big that this should give you evidence that maybe in the population there is a difference. It's not the same. Reject this hypothesis. There's evidence against the same hypothesis like that. Right? So here is the true Z statistic in all its glory. It's pretty bad. And that's why I printed it out for you in the slides. I don't want you to make a mistake copying it. It's pretty bad. Okay. You can see that the something in the square root is something quite horrendous. But it's just a little bit tedious to calculate. It's not hard to understand. Let me go through it. If your eyes are sharp, actually you'll notice a kind of a theme. You see like a pi 1 minus pi over n kind of thing happening. So yes, so they are fair. Now, why they are similar is beyond this clause. You just accept it as a formula. That's why I have let you have cheat sheets and all that. I don't expect you to memorize this. That would be cruel. Right? I don't want you to memorize it. You probably get it wrong anyway. All right. So this, okay, so I mean it's so long. Okay. You know, even me, if I don't use this for maybe a year or something, I might actually forget it. It's a monstrosity. Okay. So you have this. I want you to pay attention though. Do you see everywhere there's a minus sign, minus sign, minus? There is one plus sign. That's correct. It's not wrong. Please be careful. There is a plus here. This is correct. Everywhere else is minus, but there is a plus here. So please take note. All right, that's correct. Okay, so the only new symbol here that we don't know is what's p hat pool. We've not talked about this. I think everyone knows what n men is, right? How many men were there? How many women? N always means that. How many men? How many women? P hat men you already know. We've already done a worksheet. What's p hat pool? Well, here's the mathematical definition. I don't want to get to that first. P hat pool is just the overall gun ownership rate across men and women. It's actually what Jennifer was mentioning a minute ago, where she said they pool. P hat pool is exactly that. You take all the male and female gun owners and just find a rate of gun ownership in the whole sample that you have. It's an overall gun ownership rate. So if I show you the work for P hat pool, it's going to make sense. See what I did? Okay. Now I encourage you, please take a picture of this. Okay. Don't copy because it's a lot of horrible, ugly numbers. So I'll move away and you can take a picture. Okay. I should have taken a picture of you all taking a picture at the same time. That would have been pretty cool. Everyone raised their phone at the same time. That was great. We'll do it next time. Right? Anyway, so do you see what I did for Fiat Pool? What am I doing? I'm adding, isn't 821? If you go back to your slide, okay, it's easier for you to look at your slides than for me because I have to go back all. If you add up how many gun owners there were 821 male gun owners and 402 female gun. I'm just adding all gun owners and dividing by everybody. There were almost 4,000 people in the data set. Isn't this an overall gun owner rate? Irrespective of sex? That's why it's called pooled. I'm pooling the information together. You take all the gun owners, add them up, and you divide by everybody. This gives you some kind of overall gun ownership rate. That's why it's called peer pool. And now does this definition make sense? Total successes among men and women. So successes means yes, I do own at least one gun. Yes is typically the success rate, success definition. So you add up all the yeses. Right? How many yeses did you have among the men? How many yeses did you have among the women? Just add them up. And you divide by everybody. So that gives you P4. That's the only new number here. The rest is just arithmetic. Horrible, I know. And so if you need advice, if your calculator skills are a little bit challenging for you, please do this in chunks, like what I've done. Calculate the top, write down the answer to 6 decimal places, something like that. Do the bottom separately, write down the answer, and unless you're a parentheses queen or king, and you open, close, open. Okay, if that's not you, because it's not me, I hate parentheses. Okay? On a calculator, it's already hard enough to see already. It's so small. So sort out your work, do it step by step. It's better to take a little bit more time and get it correct than to do parentheses, and get it all wrong. So do it in chunks, like what I've shown in the worksheet. All right? So it's just arithmetic. It's nothing to do with statistics actually. But look at the size of the Z statistic, 11 something. I don't think we've ever had one this size in this class yet. This is huge. Now, are we surprised? Did you detect that? Look at the difference in the gun ownership rates for men versus women. Almost 17% different. You have a sample that gave a difference of 17%. Big enough for you? And are you surprised, therefore? Isn't that going to give you strong evidence against the hypothesis? The status quo says that men and women own guns at the same rate? Yes. This is a shocking difference. Very, 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 very large. And that's what's going on. So you get the Z statistic out. You get this number here like that. And then you go to your Z table. I'm going to show you how to get the Z table to look at it, but there's no real need, because if you have spent any time at all looking at the Z table, I think you would have realized the Z table has its limitations. Doesn't the Z table end at like 3 something? Where's 11? Not even on this page. Right? What does it tell you? By the time you're at 3.5 something, you already have accumulated 0.9998 area on the left. Now, this is a right side test, so the area on the right is 0.0002. So theoretically, the p-value is tiny, so small, and that is why we will say the p-value here is, if you use the, okay, the p-value is close to 0. If you want to be technically correct, according to our table, the p-value is less than 0.0002. It's actually less than that, much less than that. It's really, really close to 0, and this leads us to very strong evidence against the null. And you would say that there's strong evidence to say that men and women, men own guns at a greater rate, higher rate than women do, which I guess is not a surprising result. I purposely picked a very glaring difference because it's easier to teach when there's a very obvious difference like that. We've covered a lot of ground. Does anyone, and I didn't ask whether anyone has any questions. Is anything making you confused about this new thing so far? No? Okay, so give it a think when you go back and read through your notes. It will make more sense. The principles are the same. Look at your observed statistic, look at your status quo statement, which is always the same. The status quo is always pi men minus pi women is 0. Calculate Z, consult Z table. That's it. Okay, last slide for today, and then we end early because this class is always super fast in answering things. There are VCs because this is a theory-based test. All right. I want to ask the class, can anyone guess what the VCs sound like? I'm quite sure you know. What do the VCs sound like in this case? Yes.
Would be 10 males who own guns, 10 guys who don't.
No, I'm just about to fall down. Yes, that is 100% correct. Why is this success? You didn't even say success, failure. Good. Don't say that. You can, but tell me what a success is. Yes. Why is there a success failure structure? Are these proportions that we're interested in? Yes. When you have a proportion problem, it came from a yes or no question. So that's why you don't have at least 20 and not too skewed and all that nonsense. It's not here. This is at least 10 successes and at least 10 failures in both groups. And actually Noah's answer even better. Don't say success. You can put success parentheses, owning at least one gun, and failure, not owning at least one gun, or don't own gun, something like that. So a success is defined as a yes, and yes here means I do own at least one gun. You know what I'm trying to say? So you need, the only difference between what you know last time and what we are learning today is this has to be true for both groups. Among the men, you need to fulfill the VC, and among the women, among the groups, every group must fulfill the VC. Now, if you learn visually, here's a picture. Your data table should look like this. There should be at least 10 people in every box. There should be at least 10 people in every box. Then you are free to use the methods that you've learned. All right. What are successes and failures here? I believe I have covered this. A success here would be someone being a gun owner, and a failure is someone not being a gun owner, by definition of the yes and the no. Okay, I think this has been an excellent class. Go give your notes a read. Uh, and it will make a lot more sense. We'll continue, we'll pick this up exactly on Thursday. Thank you very much. Please leave all your things here, okay? Thank you.